Hey guys, Mr. Jenkins back here for the second part of lesson 5.4. Hopefully you watched the day 1 5.4 video yesterday, or even today if you're watching this video ahead of time. And if you are, good job. But this will wrap up our 5.4 kind of instruction. All right. So just to recap, kind of what we talked about a little bit. We're talking in 5.4, we're talking about point slope form, where it's this funky looking formula, y minus y1 equals m times the quantity x minus x1. But the big thing is, the big picture is that if I give you a point that a line goes through and the slope, you can use that to develop a point slope equation. Okay. And our learning target before we move on is we want to be able to write and graph linear equations using point slope form. All right. So in example 1, that goes through how to just kind of sub in, given a point and given the slope, how to sub in to make a point slope equation. Example 2, more like something you might see on a test. If I give you a point slope equation, you're able to graph it. Example 3 gets into, sorry, my computer's having a tough time here, gets into if I give you a graph, then you can give me a point slope equation. So before we move on to the last example, I wanted to do C, which I skipped over on day 1, because there's something I want to show you that'll lead into our last example. Okay, and it'll be a good review of what we did yesterday. Okay. So if I want to develop a point slope equation, I need to know at least some points that it goes through. So this looks like a corner point. Looks like we have one there. Let's just make sure if we go up 2, right 3, if that is still on the line. It appears to be. Okay, so it looks like my slope is 2/3, and then we can use any of those points. So let's just use this one right here, the first one that we had, -4, -3. All right, so that would be x1 is equal to -4, and y1 is equal to -3. All right, and then our formula, I'm copying down right now. Y minus y1 equals m times the quantity x minus x1. And remember, we sub in here, here, and here. X and y stay, okay? So when we do that, we get y minus, it says -3. So minus negative shows up as a plus, so y plus 3 equals, we're subbing in for m, 2/3, equals 2/3 times the quantity, x minus, instead of x1, we're subbing -4, so that shows up as plus 4. All right, so I know we have the different colors, but that says y plus 3 equals 2/3, parentheses, x plus 4, okay? Now, that might look different if you use the 0.21, right? Which might have been what I used on the notes. I don't even remember, right? So you might want to cross-reference there. Here's where we can tell if we all have the same exact equation, okay? So I'm going to work on now, and this will transition into the next lesson. What if I wrote that in slope-intercept form? So now I'm going to take this, and I'm going to solve for y, which is actually what we're doing on the DMR, right? So if I want to solve this for y, the first thing I'd want to do is distribute the 2/3, okay? So that's going to give me y plus 3 equals 2/3 times x is 2/3 x. 2/3 times plus 4. If I type that in, I'm going to get a fraction, right? Because that's just equal to 2 times 4 is 8 over 3. And 3 doesn't go into 8, right? So I'm just going to put plus 8 over 3. All right, and then what I would want to do from there is subtract 3 from both sides to move that over. Okay, so that would give me y equals 2/3 x, and then whatever 8/3 minus 3 is. So I think of that as 8/3 minus 9/3. That'd be minus 1/3, or minus 3.3 repeating. Now, we know slope-intercept formed a little better, right? So we already know our slope is 2/3. We talked about that. Let's see if our y-intercept of minus 1/3 makes sense. So does it look possible that that could be the point 0, comma, negative 1/3? It does to me, so we've probably done that correctly, okay? So if you had to do this on a test, I don't think it would be quite such a hard problem, but you do have the ABC button and stuff. In other words, on this step, you could type in 8 ABC 3 minus 3, and it would just give you minus 1/3, okay? All right, so that leads us into the last example, example 4. I think you have one on the, at least one on the homework like this. So let me go ahead and pull up my calculator. Let's have that pulled up, so just bear with me a second. And I wanted to go through how to get slope from a table one more time. Sorry about the delay here. All right, so let's look at example 4A and then maybe C. So our directions are, it says we want to basically come up with a point slope equation and then a slope intercept equation. All right, so looking at A, the first thing I'll need is my slope, right? So my runs are pretty easy, right? I know 10 plus 20 is 30, and 30 plus 40 is 70, and then 70 plus 20 is 90, right? But they're not so obvious here, okay? So I just wanted to remind you, you know, we don't really know. 640 plus what is 590, right? So if you can't tell, you just do the second number minus the first number. So 590 minus 640. To get negative 50. That tells me we did minus 50 to get from one to the next, right? And then on our other one, 490 minus 590 would give me negative 100. 440 minus 490 would give me negative 50. Okay. Either way, though, we should get that our slope is negative 50 over 20, which is equal to negative 100 over 40. Okay. Give my computer a second to get caught up here. So those are both equal to, looks like negative 2.5. That's my slope. Negative 2.5 meters per second. All right, so we have that, and now we want, if we want a point slope equation, we have the slope, we need a point. Right? So you can pick any point you want here, right? I usually just pick the top one. So if I pick the top one, that means that x1 is equal to 10 and y1 is equal to 640. Doesn't matter which ones you pick, okay? So now we sub in, we have y minus 640 equals m, which is negative 2.5, times the quantity x minus x1, which is 10. So hopefully that all pops up here in just a second. And there it is. Now, so this is my point slope equation. So that's part 1 of my answer. Part 2 of my answer is I want to solve that for y. I'm going to distribute the negative 2.5. which should give me y minus 640 equals negative 2.5x plus 25, negative 2.5 times negative 10. Now I'm going to add 640 to both sides to get y equals negative 2.5x. Just go through that math real quick. So we did negative 2.5 times negative 10. That gave me the 25, and then I would want to add 640 to that to move that over. So plus 640 gives me 665. Plus 665. So point slope kind of seems like a weird thing that we would never need, but it is nice to be able to come up with a slope-intercept equation if you get good at that. Okay, then our last question that I'll cover is example C here, and then hopefully you can look at B and try to do one of these on your own, right? Because there's only one like this on the homework, so it's a good question to be able to do on your own. All right, so first things first, let's figure out our slope. 8 minus 28 gives me negative 20. Negative 3 minus negative 7 gives me plus 4. And then you could make sure that they're all equal all the way through. So negative 2 minus 8 would be negative 10. Negative 1 minus negative 3 would be plus 2. Sorry, my computer is not keeping up. That'd be a lot nicer if it would. And then, sorry about that. So negative 7 minus negative 2 would be minus 5. 0 minus negative 1 would be plus 1. So my slope, this just kind of makes sure that it's linear all the way through. So negative 20 over 4 is going to be equal to negative 10 over 2. And I'm going to stop for a second, let that all get caught up. And that should all be equal to negative 5 over 1. All right, so anyways, my slope is negative 5. So I have that, and just to show you that it does not matter which point I use, let's just pick a random one in the middle. Let's say that one, okay? So x1 is negative 3, y1 is 8. So my point slope equation using those would be y minus 8 equals m, which is negative 5. Negative 5 times the quantity x minus negative 3, so x plus 3. All right, so that's a point slope equation. And we'll solve for y to get our slope intercept equation, which we can tell a lot better. Okay, we know slope intercept a lot better. Okay, so y minus 8 equals, now we're going to distribute the negative 5. So negative 5x minus 15. And then we have y equals negative 5x. Then we have negative 15, and then moving that over. So we're going to plus 8. Negative 15 plus 8 would be minus 7. Okay, and that should be my rule that maps any of these x's to their corresponding y. In other words, if I plug in negative 7, that would be y equals 35 minus 7 is 28, so it works there, so we can feel pretty good about it. Here's another thing we can sell. Now that it's in slope-intercept form, we can sell the slope as negative 5. Also, we can sell that b is negative 7, and what do you notice right here? They give us the point 0, comma, negative 7. So they actually gave us b straight away there, okay? So just little stuff that you can look out for that is helpful as you work through all of these linear equations, okay? So you know slope-intercept form, y equals mx plus b. Hopefully you're getting to know point-slope form. And then we will have a day or two of review, and we'll take a quiz over everything we've covered so far in Chapter 5 before we move ahead, okay? So make sure you're asking questions if you have any, and make sure you're keeping up with that practice. And, you know, hopefully this helps. Thanks for all your hard work, and have a good one.